This is a very simple model about the arithmetic between GDP and debt. I want to begin by noting there are no policy implications in this model. It's too simple. All the various rates here, R is the growth rate of GDP, G is the government spending rate, S the tax spending rate, I the interest rate. They're all treated as determined outside the model. They're exogenous, and there are no feedback loops between them, so there's no policy discussion here. This is just to explicate the arithmetic. Let me begin by looking at the GDP growth rate, R. 2.8% is the annual rate. These periods are taken to be quarters, so this 2.8% is converted to a quarterly growth rate, about 0.69%, and that determines this curve. If you lower the growth rate, let's do that a bit, it grows at a slower rate and shifts that curve down. If you raise it, I'm going to raise it back to 2.8%. It gets it there. The maximum for R is 3% in this simulation. These are all interpreted as real values, so no inflation whatsoever. 3% growth on a sustained basis is fantastic. Let me talk about how to think about this curve. 2.8% is kind of a magical rate. You want to look at how many periods it takes to double, to go from 100 to 200, and this point over here where it doubles is just about 100 periods, and so another 100 periods you get another doubling up to 400. It's not exactly that, but it's pretty close in the graph, and so that explains the shape of this curve. The government spending and tax revenue curves are pretty closely related to each other. They're both assumed to be proportional to GDP, and that is just to make them, for simplicity, you can vary government spending independently of varying the tax, so they are not assumed to be related. But what I do want to say is that varying the tax or varying government spending have symmetric effects in the model. So those are, oops, let me close this, and in fact let me close my mail for a second so we don't have that interfere. The next thing to note is that this graph is at the scale of GDP. Deficits, which are the difference between government spending and the tax revenue plus interest on the debt, are hovering above the horizontal axis. They look real small at the scale of GDP. So what counts as a big deficit versus what counts as a small deficit is something to try to explicate with this arithmetic. That's part of the goal here. The last curve to point out is the debt, and this graph right now is set at what you might call the nightmare scenario, where the debt to GDP ratio is rising throughout and is getting perhaps in an uncomfortable zone, even though it started out as 1/2. Debt is growing faster than GDP throughout. And the reason that's true at the current levels is the rate of growth of the debt is the deficit to debt ratio, and the rate of growth of GDP, this is the quarterly growth rate here. So the deficit is growing faster than the debt is growing faster than GDP throughout, and so that's why you have the picture as you do. In order to bring things to balance, you would either raise taxes or and let me get close to balance. That looks pretty good right now. The blue curve is still a little bit above the red curve, but not so bad. Let me go one more, and now we've got them. They're basically coincident, and this is like perfect balance. And notice that the government rate is still above the tax rate, and the reason for that is the GDP growth rate, R, is bigger than the interest rate, I, at the present. So let me talk about that for a little bit. there's no reason to believe these two things are the same. The interest rate is determined in global credit markets. The GDP growth rate is for this particular country, and countries grow at different rates. So the fact that R and I can diverge is part of what this arithmetic exercise is about. For those countries where R is greater than I, you can have this sort of balanced growth where the debt to GDP ratio is perfectly flat with a structural deficit. This deficit is persisting for the whole 200 periods. A lot of the discussion about debt and GDP are implicitly assuming that R equals I, and that really doesn't need to be the case. Now, you can do other sorts of comparatives here, so you can change the initial debt level. And so let's make it 125. Get it up a little bit more. And so here's a case where you see the debt to GDP ratio is coming down. If you wanted to make it come down a little bit more, you could do something of, raise taxes a little bit more. We're still running a deficit here, but we're getting, if you will, the debt under control this way, and long term this would be fine if we were doing this. So the point of this exercise is, if you're in an R greater than I regime, small deficits are not a big deal. Big deficits are a big deal, and what small and big is depends on these values. So let me just say you can play with the regime where R equals I. I won't do that here. If you did that, then indeed you would like for balance to have G equal S. That is basically government spending would equal tax revenues. If you're in a regime where I is greater than R, then G should in fact be less than S, and you should run surpluses so you can pay off that extra interest. So let's see if